All right, so section 4.1, we're going to be talking about quadratic functions. So there are things that have like a power of 2, so like an x squared type of thing. Okay, now they're going to be wanting us to graph a lot in this homework assignment, but then every once in a while they're going to want you to find a vertex, whether it's a maximum or a minimum, stuff like that. So I'll discuss all that stuff with you guys right now. Okay, so let's start off with the vertex form. Okay, so the vertex form of a quadratic function. Now, like I said, it's going to look pretty familiar, okay? So check this out. So there's the vertex form, okay? Y equals a times the not absolute value, sorry, times x minus h quantity squared plus k. So notice the main difference is that before we used to have absolute values around x minus h. Now we have parentheses with a square on it. That's the main difference. Other than that, everything behaves the same way. All right? Your h moves left and right. Your k moves up and down. If h looks negative, you move right. If h looks positive, you move left. If k looks positive, you go up. If k looks negative, you go down. Right? We've talked about this before when we were discussing absolute value functions, and that was section, I think, 2.5. All right? So you can always go back and look at my notes on Google Classroom. You can look at your notes if you got them. But it's going to have the same behavior, okay? Now, a real quick reminder. Your A term. We call this our amplitude. Okay? And I'm going to remind you, it's like, let me call it the first slope. This is not an actual math term, okay, the first slope. It's just a made-up thing. But it's a way for you to remember what to do with your graph. So let's just call that the first slope. That's going to help you find, once you have your vertex, it's going to help you find the next 2 points really quickly. Okay? So your A value is very important. What is it? That way it helps you move in a certain direction or directions. Okay? So that's our amplitude. Now, I'm not going to rewrite that H goes left and right and K goes up and down. I mean, we've already been doing this for a month. Okay? So we don't have to worry about having to write that stuff down again. But there's a couple other little things I want to remind you guys about. If they ever ask you to find the vertex of this type of function, you're still going to look for h comma k. Okay? So, I don't know where that was, but you're still going to be looking for h comma k. All right? So, there's that portion. Now, in reference to the vertex, okay, or how can I put this? If A is positive, okay, I'm just going to put a plus sign there. So if A is positive, let me bring this up a bit. So if your A term is positive, the graph opens up like this. Okay? It opens upwards like a U shape. So the vertex, so the vertex is called a minimum. Okay, now I'll show it to you right now in the picture. But it's going to be at the very bottom of that U shape. So it's the minimum point at the very bottom of that graph. So they're going to call it a minimum. Okay, so if A is positive, then your vertex is a minimum. If A is negative, yeah, it's just going to switch. Okay, so your graph's going to look like this. So the vertex is a maximum. So it's called having problems writing right now, called a maximum. So let me kind of highlight that. If A is positive, we're going to call it a minimum. So vertex minimum. If A is negative, then the vertex is a maximum. And that's pretty much the only thing you guys have to kind of, I guess, be retaught, if anything. Hopefully the HK, all that, the big old paragraphs we used to write about that. You can always look those up. Okay, we don't have to rewrite that. But most importantly, when you're graphing, you need to know, what is your A term? Does it open up? Does it open down? Is my vertex a high point or is it a low point? That all depends on A. And then your A term, your what I call the first slope, even though, again, not a mathematical term, you won't find it in any math book, okay? But what I call the first slope kind of gives you a fast way to graph these things. Instead of making an XY table and like finding 5 different points to plot on a graph and then you get to graph it, you can just use your A term to figure out your next 2 points, and then from there you can sketch it, okay? So, and all of these problems they're going to make you do, they all say sketch the graph, not graph it exactly. They're saying sketch it. So in other words, give them a decent idea of what it looks like, but it doesn't have to be perfect. Just a decent idea. All right. So let's do a couple of these problems that you guys have here on your homework. So here's example number 1. Maybe we'll do 3 graphs and then we'll move on to some other stuff. So we're going to sketch. All right. So we're just going to be sketching. And part A, y is equal to 2 times x minus 4 squared minus 4. Now I'm going to draw a pretty decent sized graph because of the fact that this is going 4 times down. So I'm going to try to make like a 5 by 5 graph. Okay, just to make sure that my my graph fits. Now, as always, I always tell you guys, they're graphing, or they're giving you a graph already, so you don't have to worry about drawing these things out, but at least for now, I'm having to do it. So this is going by 1, so 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay? Now, honestly, guys, when I learned how to do this, it would take me a while, because this is what it would look like. I would get my equation, and by the way, don't write this down. Don't write it down. I would do a table, okay? And then they would tell me, okay, pick 5 points. So I'd say, okay, well, why don't I try picking like a -2, -1, 0, 1, and 2. Then I'd have to plug them all into my equation and find answers for all of these and then plot them all down. That would take me about 2 to 3 minutes, maybe more, depending on how hard the equation was to deal with, okay? I don't like to do that anymore, and I don't like to teach it that way because that's just a long waste of time, okay? So we have calculators that can give you great graphs, right? So if they want you just to sketch it, well, let's find a nice quick way to sketch. So this is how you do it. Your very first thing you want to do, so right now you can start writing this down, is you're going to want to find your vertex, okay? Now remember, my vertex is HK, so what is my vertex according to this equation? 4, -4, good, so it's 4, -4, okay? The H value is right here, okay? That's my H value. My K value is over here. All right, now remember, for H, it's always opposite, right? It says -4, so we're going to write +4. K is exactly what you see. So you see minus, so put minus, okay? So we're almost done, just so you know. This is supposed to take a long time, but we're almost done. So 4, -4, that's right here. So I already put my dot. I just need 2 more dots, one on each side of this point. What is my amplitude? A is equal to 2. If this was a slope, what would I call it? 2 over 1. So look what I'm going to do. From my point, it's a +2, so I get to go up, right? I'm going to go up to 1 over, but then I'm also going to go up to and 1 to the other direction. So up to 1 over this way. once I do that, I'm just going to connect my dots, and I'm done. There's my sketch. Like, this can take you 30 seconds or less. Okay, depending on how fast you are at noticing stuff. This can easily take you 30 seconds or less. Now I'm curious, is my vertex a maximum or a minimum value? It's a minimum, and for two reasons. Number one, you can see it's at the very bottom of the graph, but the second reason is your A value is positive, and we talked about a positive A value, right? If A is positive, it's a minimum, right? If A is negative, it's a maximum.
Did you get the positive 4?
Oh, right here. So remember, it's H, but opposite, right? Just like with the absolute value, how H was always like the opposite of what you see. It's the same thing with the quadratic function. It's going to be the opposite of what you see. Now the K value, the one on the outside, that one's exactly what you see. If it's minus, you put minus. If it's plus, you put plus. But yeah, the one inside the parenthesis is always the opposite. Any questions on that one? Uh-huh.
How long does it usually take, like, if you did the table?
If you did the table, it depends on how fast you are. So if you're good at your math, you could probably get the table and everything done within 2 minutes. Yeah. I mean, now if I were to do it, I could probably do it in like a minute. But if I would have not talked to you guys in this problem, I would have immediately drawn my vertex, seen the slope, gone 2 up, 2 over, right, on both directions, drawn it, and that would have been it. So yeah, how fast you do these problems really depends on you, right? But for the most part, it won't take you more than a minute, even if you kind of work through it slowly. So let's do another one. Whoops. Another one from your homework. Go ahead. Oh, sorry about that. So yeah, let's do another one from your homework. I'm just looking to see what's available right now. We can try this one, and then I know what we're going to do after. But negative 4x minus 2 squared plus 4. Okay. So I'm just looking at all the other problems you have. That way we do something similar to all of them. So let's go ahead and create a sketch for this one as well. I'm going to do a 5 by 5 as usual, just to have enough room. Sometimes students will ask me, like, how do you know that it should be like a bigger graph? Like, why don't you make it only like 3 left, 3 right, 3 up, 3 down? It depends on what I see. So if I see that my K value is making me go up 4 units, so I know it has to be kind of high, right? I only have to move twice to the right, but up 4. So I got to make sure I give myself enough room for that. And then I notice the amplitude is 4. It's a negative 4 there, but I know it's 4. So I have to think about the fact that it's got to move 4 units up or down from wherever I start. So I got to give myself that room. All right. So again, this is all done in a scale of 1. So 1 through 5. Okay. What's my vertex? 2, 4 is correct. So let me go ahead and put that 2, 4. That's right here. Okay, 2, 4. Now, what's my amplitude? Negative 4. Now, if I think of it as a slope, it's going to be negative 4 over 1, right? Negative means I have to move downwards from my point. So I'm going to go down 4 units and once to the right, down 4 units and once to the left. You're doing both directions. Notice that's completely against the way we do slope, right? We don't normally do slope like that. We only move to the right and only once, right? We don't do left and right. That's why I call it, I put it in quotes, an actual first slope in quotes. So 4 down and 1 to the right would be right here at 3, 0. And 4 down and 1 to the left would be right here at 1. So all I got to do now, connect the dots, and there's my graph. Again, this is supposed to take a long time. Okay? So I'm telling you right now, the way it's supposed to be done is you're supposed to pick a bunch of points. Okay, pick a bunch of points and then you know, try to figure out. Sometimes you pick the points and all it does is it only shows you like this section of the graph and you're like, oh man, like I don't see the curve, which means you got to pick more points so that you could get the other side of the graph, right? And if you pick the wrong direction, then you got to pick more in the other direction. So you end up like calculating 15 points trying to figure out where the heck is this thing changing direction, right? So if you do it this way, you know exactly where you're centered. They call this your axis of symmetry, your vertex. We'll talk about that in a bit. But you know where the vertex is, and then you know where your first 2 points are going to be. Now, is this vertex a maximum or a minimum? Yeah, this would be a maximum. And again, you can tell two ways. Number one, because we graphed it and you can see it's the highest point. But number two, A is negative, and I wrote that in your definition. If A is negative, it's going to be a maximum value. Okay? So here's one more. Let me give you guys a little bit of time to work on this. I'll pause the video here. But let me have you guys try one of these. Let's see. Try this one. F of x is equal to, now remember, f of x is the same as y, okay? So don't let that scare you. Okay? It's the same thing as y. And then after this, we're going to talk about little pieces of information that you have to know. But we would have been done with all the graphing portion. So go ahead and do that. Let me pause the video, and then I'll start it up in a bit. All right, guys. So let's graph this thing. So first thing you want to do is find your vertex. And what's our vertex? 1, 2. Let's see. Not -1. Yeah, -1, 2. Remember, the h value is always opposite of what you see, right? So I see a +1, so it's got to be a -1, right? So -1, 2. Let me go there. -1, 2. That's right here. Okay. My a term is a -1, and if we think of it like a slope, we think -1 over 1, right? So I'm going to go down 1 over 1, so right here, and then down 1 from the red dot again over 1, that's going to be right there. And then all I have to do is just draw my picture, and I'm done. That's it. Okay, again, they're making you do 8 of these. It really shouldn't take too long. Okay, I would say if you're efficient, 8 problems in 8 minutes is about right. Okay, if not, I mean, go ahead and take your time. But if you kind of get this and you're like, yeah, this isn't so bad, then it'll probably take you about 8 minutes total to do the first 8 problems, maybe less. Okay, so all right, now there are 4 different topics. Now, one of the topics that they want me to cover is the vertex a maximum or a minimum? But we already talked about that, right? I wrote that up here. Okay? This is how you can tell if a vertex is a maximum or a minimum. It's based on your a term, and if it's negative, it's a maximum. If it's positive, it's a minimum, okay? Because the graph will open up if it's positive, okay? So I don't have to discuss that with you guys. Another question is, what is the vertex of the quadratic function? Well, we've been doing that, right? These last 3 examples, I've been telling you, what is the vertex? What is the vertex? So you guys just have to write it down. And remember, I did give you that definition right there, right? It says vertex is h comma k, right? So we've done that. But then they say 2 other things. And right now we're going to do the axis of symmetry last, but let's talk about transformations, okay? In other words, movement. So I do want to remind you guys that you are going to have to write equations down now. Unfortunately, I'm sorry, example 2. Unfortunately, in your homework, they did all 4 problems already. Well, the answers are there, shall I say. They did all 4 of them for you. But they are going to ask you the following. Okay? Write an equation, or shall I say, write a quadratic function that they use the word translates. It means shift, okay? So that translates, I'm going to put in parentheses shifts, 3 right and 2 2 up, let's say. So all they want you to do is to write the equation again. Okay, now remember the equation they're talking about is this one right here. Now, remember what we said before with the absolute values? If they don't give you an A value, then we should write what? A 1, right? So that means A is 1. So let me put Y equals 1. X. Now, what's my H value? They said 3 to the right. Negative 3 squared. And then they say 2 up. Yeah, plus 2. And I'm done. Notice, is this any different than the absolute value stuff that we did? Well, with the exception of the notation, instead of the parentheses, we were using absolute values, right? But everything's the same, right? So this is why I told you guys, when we do this, don't get scared like, oh my gosh, this is so different. It's literally the same thing, just with a different type of function. It's going to have the same movement, left, right, up, down. It's going to have your amplitude and everything. Now, you don't have to leave the 1 there if you don't want to. Okay, if you want to rewrite it like this, that's perfectly fine. Okay? You had a question?
What does the exponent do?
It's a square. It squares the graph. So what it does is that instead of the graph, the question was, what does the exponent do? So normal graphs are nice straight lines, but when you have an exponent, every other point gets squared. So like if x is 1, the square of 1 is 1, so it's 1, 1. But then if you try 2, 2 becomes 4, 3 becomes 9, right? 4 becomes 16. All of a sudden the graph is no longer a straight line. It's curving and it's going up faster and faster, right? So that's what the power of 2 does. It makes the values grow quicker. It's not a nice uniform growth. Now, just out of curiosity, what if, and then right now we'll do the axis of symmetry. So example number 3, write a quadratic function that translates, remember that means shifts, we'll say 4 units down and opens down. This one's a little, I don't want to say it's tricky, but it's a little different. Write a quadratic function that translates or shifts 4 units down and opens down. So remember, this is our formula, y equal to a parenthesis x minus h quantity squared plus k. What's my a value? Negative 1, right? Negative 1. Good. Because it says it opens down, so that means a has to be negative, right? And then x minus, what is my left to right movement? Does it have left to right movement? No, so let's write 0 squared. What about my k value? 4, positive or negative though? Negative, right? Because it's going downwards, right? So they will clean this up a little bit for you guys. X minus 0 is x, so this is just going to be negative x squared minus 4. Okay, so you might see stuff like that. Because they just simplified it, that's all. Whenever you get to put a 0 in, they always want you to simplify it. If you don't have zeros, then just leave it alone. All right, so this is the last thing. This is actually the only thing in this lesson that you guys are going to learn that's brand new. Okay? The only thing you guys are going to learn is brand new is going to be this next thing. It's called the axis of symmetry. Okay? And if you took Math 2 last year, which you all should have, at least, maybe not last year, maybe 2 years ago. But if you did take it, you've heard of this before. The formula is this. X equals negative b over 2a. Now, what are they talking about in terms of negative b over 2a? That is if your formula looks like this. Y equals ax squared plus bx plus c. But our formula doesn't look like that. Okay? So we have a different equation. It's actually easier. X equals h. If your formula looks like this. So you don't have to worry about plugging in tons of little numbers and fractions. No, they just want to know your axis of symmetry, the line that cuts it in half perfectly. The equation of that line is x equals to h. Okay? So all you got to know is your h value. That's all. So just out of curiosity, let's just do a real quick example and then we're done. So example number 4. Identify the axis of symmetry. Now you guys can always abbreviate that AOS if you want to. Okay? The AOS. And remember, your axis of symmetry is going to be x equal to h. All right? So we're going to do 2 quick examples. It's going to take us it's going to take me longer to write the problem than to actually do it. So here we go. Y equal to 2 times x minus 1 squared plus 3. What is my axis of symmetry? 1. We're done. That's it. Okay? Isn't that great? You don't really have to do any work. Again, it took me longer to write the question. Right? B, y equal to negative 1/2 parenthesis x plus 3 squared minus 10. What's my axis of symmetry here? Negative 3. Done. Axis of symmetry is negative 3. Okay? And that's it. So I'm going to stop right there. I'm going to give you guys your homework. Like I said, I know that there's 16 problems in it. They already did 9 through 12 for you. So if anything, like I said, just double check them.